It's a pleasure to have Elif here.
And let me just remind you her kind of biography. She obtained a PhD in bioengineering in 2011 from University of Bologna, and she has MS and BS degrees in computer engineering from Boğaziçi University. She worked at University of Milan in the EU project Revive, where she developed video games for the rehabilitation of stroke and neglect patients. She is now at the Graduate School of Informatics, Modeling and Simulation Department since 2015, where she is working as an associate professor. Her research interests include serious gaming. I don't know.
Today we are going to learn about
Serious gaming, not for fun, virtual and augmented reality, human and canine movement analysis, machine learning, and computer vision. Today she'll be basically telling us a bit about game research. She wants to give a general overview of things, which I'm also excited to hear. Without further ado, I'd like to leave the stage for her.
Thank you so much, Hocam, for this kind introduction and also for welcoming me here at ROMER. It's a pleasure. Today, I'm going to give you like a brief introduction. It is going to be a light seminar on what we are doing without going too much into the technical details, so that we will have lots of time to discuss what we can do all together. We have already started to collaborate with ROMER so far, but we are open to new ideas and new research topics as well. So today is going to be an overall view of what we have been doing. So first of all, I will start a little bit with the design thinking, process of design, because whenever we are trying to come up with a game idea, the design thinking and persona building are quite hand in hand. Then we will have a look at what the persona building is and why we do need that sort of view, because we're going to see that from our examples as well. We are not only developing games for fun, but also for elderly, for disabled people, for people with stroke and so on. So we need to have user-centric design and we need to understand that. Then I'm going to show you some examples from what we have done with METÜ Architecture, Department of Architecture, and also Bilkent University's Industrial Design Department, where we have experimented with mixed reality and virtual reality. But we will also have an overview of what these concepts do mean, how they do overlap, and how do they differentiate from each other. And then I will give an example on sketch recognition, where we are using a very simple artificial neural network, where we are recognizing some gestures and we are using it as a gameplay mechanism for fun, and how we are evaluating it. And finally, I will show some examples from our European Union projects. And we have this year we have won like 2 of them. And I will elaborate on what the future is going to bring in terms of the collaborations. So we have mainly like 3 stages of design. One of them is the concept, the other one is the elaboration, and the other one is tuning. And my students from the physics for computer games or game development pipeline who are within the audience will remember those steps. So as the name suggests, first of all, we are trying to look at the game design in terms of a concept. I mean, what are we trying to do there, for whom, and who will be the actors, in which environment, and so on. And this should be decided with a back and forth way of looking at things. And once we do decide on that, we will start coding, elaborating, testing, and so on. And once we have a working prototype, the rest will be in terms of tuning stage, where we are going to fine-tune all the parameters and how the user responds and the colors and the gameplay mechanics and so on. But the most difficult part is the inspiration. I mean, we are trying to come up with some game ideas, but there are lots of ideas, and we may have the tendency to think like, oh, that idea has already been taken. And but it's not true. I mean, even in a regular class, if we do have like 20 students, we do have 20 new ideas. But to have that, we need to have a broader creative space, and we need to communicate better with if we are doing a group project, and we need to better communicate our needs. So mainly how we are coming up with ideas is that first we are exploring. It is very much similar to the literature survey that we are doing in parts of the research. I mean, what the other people are doing, where the technology is, what we would like to achieve, and so on. Then we are brainstorming and trying to visualize the concepts that we do have. And in that stage, we may come up with like 100 ideas today, and 99 of them can be invalid tomorrow. So it is going to be like an exploration stage where we are testing new things. I'm sure that most of you have recognized it as well. Once you push too much, you get stuck. So there should be a phase where you need to pause and you need to leave some space, detach yourself, and come back to the idea later on to edit it and embrace and editing and selecting it. That's why in our courses as well, we always have like different phases, phase 1, phase 2, and final presentations, so that we can navigate the same idea, we can explore it better and change it if necessary. While doing it, the purpose is like the backbone of the game ideas or projects, or I mean, why are we doing this and for whom? That's a very important question, because we need to have a user-centric approach, and we cannot say that, okay, I do like this type of game, I'm sure that my audience will like it as well. You don't know anything about your audience, you shouldn't have any assumptions, and you need to empathize with the audience that you are trying to build those games. That's why we are creating personas. How are we creating this? First, we are trying to get some information about our user base. What are their likes? What they would like to achieve? What is their lifestyle? What are their hobbies, and so on? So we are trying to put those concepts a little bit to a flesh and bone, right? That's why to concretize our aims and to also have some use cases. This is something that we are doing both in design thinking and also in game development. So persona defines who the story is about, and we do have the scenario building or storytelling where the events and gameplay are happening, and there is a goal. I mean, this can be like the achievements in the game or the objectives that you should be doing throughout the gameplay, or for a design, if you're designing a product, what is the use of that product and what is the main aim there. So there can be some goal-oriented personas. I mean, what does my typical user want to do with my product, and why is that audience playing our game? What will be the main purpose? Or we can create like engaging personas where there will be some 3D prototypes. They will be interacting and acting on the scenarios, and they do become way more flesh and bone. Or we can come up with fictional personas, and we may put the aims that we would like to achieve with that product to a hypothetical character and imagine how they would be enjoying the product or the game that we are producing. And to better understand those personas, we can create lots of matrices where there are lots of parameters, and we can come up with some ideas about those. For example, we can start with some user surveys and try to put some commonalities in between. And we may say that, for example, as the professional activities, that person is already using some housing, uses true colors to identify others, posts his properties on social media. So there are some, let's say, professional activities. Or are there any limitations of technology? What are the behaviors and motivations of this person, goals and needs and frustrations? So let's say that we are designing a game for rehabilitation. The first question is for whom, for which age range, what is the disability, what we are planning to achieve with this game, for how long, with which sessions, and so on. So all of these are going to be concrete for us. So we will be saying that, okay, I'm developing this for a kid who is like 8 years old, enjoys running, but right now has this problem in their leg and so on. So we are creating a person, so that we are not only focusing them as like consumers anymore. So they have their own stories and they have their own aims. And that's why we need to empathize with our users. And this is true for not only for the design thinking, but also for the game development as well. So we have all these 7 questions. Who are we empathizing with? What do they need to do? What do they see? What do they hear? What do they feel? So we are trying to understand their worlds and what are we going to add to their worlds with our applications. And then, so once we do have that, let's say static persona, we are creating scenarios. And this is where the storytelling, where the gameplay comes into action. Okay, we have a user, we have an avatar, we have a player. What are they going to do in the game? What will be the main actions? Are they going to change what's going on in the game? Or are they going to follow a preset story? And storytelling is at the heart of game development because, I mean, we are all actually like storytellers. It is how we are communicating, we are consuming stories, we are reading books, we are having right now the streaming services and so on. So we are addicted to storytelling. And if that part of the game doesn't work well enough, and if the audience has an expectation like that, you may have the best technology, you may have the best gameplay, but people will not be immersed enough if your story is not believable. That's why there are different strategies for scenario building and storytelling as well. And I will give you an example from our studies as well, why this is important. If you are creating a linear story, you already know what's going to be the main outcome of the choices the player is making. But if you give the player the agency to change the things, you need to be very careful for the rest of that. You may think that, oh, that's going to be awesome. I can change the outcome. So it's going to be way more fun and so on. But think about the tree structure that you are creating via a scenario and how it's going to unfold. And you are going to have lots of endings. But each of those endings may not be that powerful. So in the end, your player may be disappointed at the end. But when you have a linear story, you know each part of it, the pace of it, and the actions available there. So it's a way more straightforward way of doing things. And that's why, surprisingly, people in general do enjoy linear storytelling more in video games, even though we were expecting something different. So let's right now switch to the terminology. I mean, I'm sure that you have heard the terms like virtual reality, augmented reality, mixed reality, extended reality, simulation, game, serious game. I'm going to tell you all about this in a brief way. So as the name suggests, virtual reality is the broadest concept of all, and all the things in that world and the objects and the things that you are interacting with are virtual. We don't have any access to the real world. With the augmented reality, the reality is actually there. And you may imagine those augmented layers like 2D layers of which are embedded on top of an image or a video, like the Snapchat filters or Instagram filters. The reality, the exact photo or the video is there, and you are putting some virtual elements on top of that, and it doesn't require interaction at all. With the mixed reality, though, you are adding 3-dimensional holograms, which are located into the real world with the coordinate structure that are built with the reality. So if I am playing a mixed reality game, and if I do shoot a bullet, I do see its virtual reflection on the real world. So it is the reality and virtuality is very much hand in hand. And also with the mixed reality, multi-user collaboration is also possible. So we can interact on the same hologram, we can design it together, change it, modify it, and so on. And all these 3 of them, the virtual, augmented, mixed, right now we do have an umbrella term called extended reality. So it covers them all because they have also similarities as well, and it's like an extension to the reality in different degrees, like spectrums of different realities. So that's the umbrella term that we are using right now. The other, let's say, three terms that are sometimes misused as well, especially the game and simulation are intermingled a lot. So video games are mainly the software, the programs that are done for entertainment. That's the main objective there. And we do enjoy them a lot. These are some of the posters from our Graduate School of Informatics 505 course. They are each semester they are creating a new game, posters, videos, and so on. And the main purpose is entertainment there. Serious games, though, I mean, I don't like this term a lot. I will come to it why. So the serious games are the games that are done not only for the entertainment, but have some ulterior additional purposes. This can be education. This can be making someone to quit smoking. This can be rehabilitation and so on. But it doesn't mean that they are not going to be fun. They will be fun. They need to be fun if they are games. But while entertaining the user, they'll be achieving additional things. Unfortunately, this serious adjective comes from the fact that the serious institutions like the hospitals, universities, and so on want such games. That's why it's called like serious games. But recently, people have started to prefer transformational games more because at the end, we are trying to change something within the user. We are trying to transform them. So it is a better, let's say, title. And these are some of the games that we have developed. I have started game development in 2013 at University of Milan in a European Union project. And we were trying to develop games for stroke and neglect patients. And then I have arrived to Turkey with a TÜBİTAK project. I had developed games for kids with Down syndrome. And afterwards, we have worked with kids with special difficulties, special learning difficulties as well. And we have done lots of serious games in cultural heritage, training, and so on. So once we have started this in Rewire, this was the project that we have started with the neglect patients. Neglect is, let's say, extension of stroke. Let's say that you have stroke on your right side, even though you have no problems with your eyes, you do not perceive the objects on your left side. So they are telling you to comb your hair, you are looking at the mirror, and you are only combing right side of your hair. Or you're eating something on a circular table, and you're just eating half of it from your plate. You're not aware that there are things there. So what we did was we have programmed this haptic device, and as you may see, it can actually work on 3 different planes, X, Y, Z, zeta planes, and we have developed games specific to those different planes. And also, let's say that if I'm always picking up the apples on the right side, the device forces me to go to the left side and pick some apples from there as well. Or while picking the apples, you are also feeling the weight of them, and this handle comes downwards, so you do feel the weight of it and you need to overcome that. And we had done a longitudinal study with those games, and we had developed a game engine at that time, and these were some of the games that we have developed using that game engine. And the idea was to rehabilitate people with stroke, and we had used it like 4 months in Switzerland, and it was possible to rehabilitate neglect after using these games, for example. And we were using color-coded feedback because the idea was having the rehabilitation at home. And think about it, you are a stroke patient, let's say having 65 years old at least, and this hospital mechanism was creating some exercises for you, and you are doing them on your own using WeFit or Kinect and so on, but you shouldn't fall down. And we need to guide the patient well enough because we would be the responsible if they had any harm. We are trying to cure people and we shouldn't cause any harm. So the main concept is that why do these serious games work? Because they have lots of, let's say, similarities with training, simulation, sports and board games, and all the structures and rule-based things that we are discussing. So, for example, we have so many nice overlaps with the education system. Let's say that we are giving students some exams, and you can think the students like players, and all those assignments can be considered as like goals in a game, and they do receive some grades and scores after they do play, or they do have some assignments which may be called like challenges, and then the final exam like the boss monster and so on. So it is very easy to use the structure that we do have in the educational system. That's the main reason why we are using it mainly in the education or training. Simulation, though, I mean, with this simulation, if I were to ask you what's going to be the weather like tomorrow at 3 p.m. in Ankara, and how many degrees will the weather be? And if you do tell me like 20 degrees, after running some models and machine learning outcomes and analysis and so on, and if you do have only answered me as 20, that's also a simulation. We shouldn't have we don't need to have the visuals. We do not interact in general with the simulations. When there is interaction or the player has the agency, that's a game. That's a different mechanism. So I will start with some of the examples that we have done with İpek Hoca from MITÜ Faculty of Architecture. We have started to collaborate with İpek Hoca in 2017, and we are still guiding students together. We do have a project together. So I hope that this black background doesn't disappoint you, because this is actually a mixed reality outcome, and the real world is behind it. So you do see all these objects, the virtual ones, and you do have this tool to design a three-dimensional software which has been designed by our students. And you can easily select some objects, create some designs and 3D objects, and put them on real tables, see how it goes. So what is the motivation here? Because the thing is that with the Faculty of Architecture's basic design course in the first year, the students are expected to think in three-dimensional. They are given all these cards, and they are trying to use the scissors and so on. And the material is quite expensive. And once you are not familiar with thinking in three-dimensional, you are wasting a lot of material as well. So we said, why don't we start thinking, first of all, in three-dimensional with the mixed reality for basic design course of Faculty of Engineering. And then after the students do achieve things, they may use the real tools. And also we wanted to understand, how do the people make decisions? And we had used this linkography methodology. So these are some of the features that you can achieve with our tool. You can scale it, you can turn things down, combine them, match them, like a typical design software, and all the capabilities were there. So you can select different objects, you can transform them, like grouping, ungrouping, and so on, scaling and changing the scale, etc. And we had used this linkography in order to analyze how they have come up with that final design. I mean, for example, here they had made several different decisions, but then went back, changed their design. So it is possible to understand in how many steps they have arrived to those design decisions, and what were the critical moves there. So it was possible to decipher their design and thought process. And these were some of the screenshots from our students from the Faculty of Architecture, where they were designing complex objects. So for example, one of the examples were something like that. They were combining them in different options, and they were scaling them, changing them, and this was an end product, for example. And we have also done a BOP project which has started like in 2017, but went like till 2021, and it was the basis of several of the studies that we have achieved. So this is my room at the Informatics Institute, and we have put this guitar-like room and house there. So what we are doing here is that this is a tool where you can create it. I mean, the architects, again, they are using a ready-made tool, which is called BIM structure, and they have all this Revit software, and they can design things there. And we have designed this, let's say, back and forth mechanism in between. So if I am changing something on my PC, I can see the outcome immediately on HoloLens, vice versa. If I do add new, let's say, doors or windows and so on, I can see its outcome immediately. And you do see some bubbles there. It is due to the fact that whenever I'm adding some new, let's say, windows and so on, the light changes in the room, and we were visualizing it. If it's receiving a lot of light, it becomes way more like red, otherwise it's cold and so on. So you can use this design tool. We had not only the mixed reality version of this, but the virtual reality of that. And this is, for example, a sample room where you have, for example, a window there. That's why you have some light coming and so on. But here it's a little bit colder. And all this information comes from the Revit software, and we can update it in real time back and forth whenever we are adding a new tree there, or we are changing the thing or changing the rotation of the house. We can see how it is reflected in real time. And this was in total virtual reality. We had done the concept of the basic design, this time for the industrial designers. And we had made this time a comparative study, because I had already told that they are actually doing this paper-based design. And we have tried to understand how they will perform if they were to achieve the paper-based design versus an already made virtual reality tool where they do make different choices. So we had two groups, like VR-based group and paper-based group. And we had first some VR trials for them to get familiar with the technology itself, and then the paper, and then the VR, and then at the end, like the questionnaires. And we tried to understand how they have achieved the outcomes, how did they enjoy it. And we had noticed that there is huge potential for VR as well. And it is better to do it in VR first than testing it in the paper-based design, because you will have an idea of thinking in 3 dimensions. In another study, which was done a few years ago, we had tried something. We said, can we use a basic machine learning mechanism to create a game where the machine learning outcome is going to be a gameplay structure? And we had used the sketch for that. This was a conference paper. So we are very much used to writing and drawing and so on. And this is how we are not only expressing ourselves, but also designing the main concepts. And it's a powerful tool. And we do have actually lots of sketch-based games as well. I mean, tic-tac-toe, the hangman, Pictionary, and so on. And this gives us lots of a quick draw data set, which has like 345 different classes and 50 million sketches there. And we had chosen, I think, 9 classes from those, and these were like the sailboat, hot air balloon, key, compass, eyeglasses, etc. And the player was drawing something as a gameplay, and if it's recognized, or if it is the correct drawing to move forward, let's say that I'm drawing a hot air balloon, and then the hot air balloon becomes a reality in 3D, and then I do step on that 3D balloon, navigate, and so on. The story unfolds like that. But the main problem was that, let's say that I'm, for example, drawing something like this. The true label should have been like the eyeglasses, but it is predicted as a compass. Or here, for example, the true label should have been the hot air balloon, but the predicted label was a key, and there were problems in the gameplay. So you can imagine that there are different ways of sketching something. In the end, as you said, whenever we are even drawing a triangle, we are not making it quite sharp and so on. We have just a silhouette of things. So all these things actually should be labeled as the same. And we had used this algorithm to check the similarity features and group the objects there. We had used some CNNs and LSTMs to recognize those objects and use this as a real-time mechanism in the game. Let me give you some example. Let's say that we are standing outside of a box, and then there are some hints. The store is locked. Sketch to open, the user draws a key, for example, and then moves out, and then the gameplay goes on. And we had done a study saying that at the beginning we asked the users, I mean, would you be interested in having a game where the sketching is the main action? And people were like, oh, no, I'm not an artist. I cannot draw and so on. So we had all this negative feedback at the beginning. No, we are not interested in that. But after they do play it, since it's quite simple and we don't expect any Leonardo da Vinci there. So it was quite fun and the outcome was nice. And once the things were not working, we were giving some guesses saying that maybe you should try this one to help the outcome and so on. And based on the choices, for example, draws the hot balloon and moves to the balloon and then flies, and this becomes a mechanism there. Then we had tested it with 18 participants, and we asked if this was fun to use, if it was things to develop and so on. And the system usability outcomes were quite good. And we had also this gameful quest where we were asking if the player has felt accomplished, how was the challenge there, the competition was enough, and so on. And then the final part of the section, I'm going to talk about some of the recent European Union projects. So this has started in 2017 as a Horizon Europe H2020 project, but this was a networking project. It is called eNotice. This was handled between 2017 to 2023, and I was the local coordinator, META coordinator here. So here the idea was to form a network of CBRNE centers. The CBRN is the acronym for chemical, biological, radiological, and nuclear threats. And here, as you may see, there are like fire departments, police, and NATO, and so on. But we were there as METU, where our main purpose was to develop games. There was this tabletop exercise in 2018, which was played in France. So each of these, for example, you are seeing animation, regulation, each of those are some cells. This is a hypothetical attack to a Paris airport in a very, let's say, I think it was in Eurocop or something. And here you do see the screen. They are playing the time of the attack, 10 minutes after the attack, 1 hour later after the attack, and so on, like 5 days after the attack. And they are trying to arrange the hospitals. How can they arrange the hospitals as most efficiently as possible? So you need to send your medical doctors and emergency people to the airport while also receiving the victims and their families and also the patients who were affected by the attack. And these are all different cells who need to communicate with each other. And even with such this is a room, right? I mean, they were able to play like 3 hours or so. And they had noticed so many good practices, but also the practices to be made better. And this was another field exercise from Brussels. This time the police is trying to navigate the reason of an attack. This time it is like a June in 2018. There is a huge, again, football event in a stadium. But in parallel, in a pizzeria, some people start to vomit due to the things that they do eat. And then the police notices that there is actually a clandestine chemical laboratory, and they are trying to understand if those things that were produced were also sent to the people in the stadium, because it's going to cause a huge mess. And see the complexity of those exercises. I mean, there's this clandestine lab, civil protection, police, forensic, and so on. So they need to play all together. After that, after seeing all those similarities, we said, I mean, why are we developing a single game? Why don't we create a game generator where you have the main events and you do sketch the main state interaction diagrams in Unity, and just by changing the assets there, you are repeating most of the similar things. So we had written this main code control transition UI. This was done in 2019 at the Interface Conference, where summer workshop. We had a group of 10 students. They worked on this for 1 hour, 1 month, sorry, and they had to do all those state machine diagrams, what's going to happen once there is an attack, what's going to happen once the subjects are dead, and or how they need to interact with each other. And once you have that state machine diagrams, you can simply create very simple objects. This is the top row where you can create lots of objects and they do interact as in the scenario. And by changing their tags with, let's say, realistic assets, you can actually create these from this. As a further example, okay, I mean, so in the end, throughout the project, there were these field exercises and so on. But as METU, we were also needed to make a joint activity, but we are not experts on CBRNE, and we are an IT, let's say, focused group, right? So we, with Mustafa Erkayaoğlu from mining department of METU, we said that maybe we can work on a scenario in a real mine where there is this chemical problem and people can navigate it in real time. So what we did was, this is from Osman Gazi Eskişehir University, and this is a real mine, and we had modeled it both in virtual reality and also mixed reality. So they were at the beginning in CoZone. They played the previous games that we had developed, the 3D versions of those, the Biogarden and the hospital games in VR. And then we took them to Eskişehir and they had played them in mixed reality and in virtual reality. And then during the pandemic, in June 2020, Nejan Huvaş Hoca from civil engineering has contacted me. He said, Hocam, since everything is right now online, we need to have some laboratory games. Why don't we do this together with you? And we had a team of 4 people. And actually, we had tested them during the pandemic as well. And we had our first meeting face-to-face was in 2022 or something. I mean, the project was finished online. And then we had done other work together, and it was a nice collaboration as well. And it was published at the beginning of this year. And we had tried to analyze if this achieves the objectives of the course and how can we make it better for the students. And this year, a 2-year European Union project, civil protection, as the name suggests, e-Notice 2 has been accepted. This time we will be mainly developing new games for different field exercises with a company in Italy, and we will be doing the test of those with different complex materials. And last week, another Horizon Europe project was accepted. It's going to be a 3-year project, but in that one, we will be developing an innovation action mechanism with a German company on a completely different IT perspective. So this was it for me so far. And if you have any questions, I'll be happy to answer. As I said, I try to give an overview. It is not very much technical, but I do hope that we can start a conversation. Thank you.